talking about insertions and deletions in amino acid sequences. When a base pair is deleted or added, the coding sequence has been affected and therefore can lead to a frame shift mutation. The base pairs are then shifted and can lead to a change in the amino acid sequence, where you now have normal and mutant sequences. The mutant sequence that now has a new set of amino acids could code for a stop amino acid before the normal sequence does, leading to a shorter mutant strand and a truncated non-functional mutant protein. A real-life example of this that helps visualize the addition and deletion of a base pair. Here I drew a train on the tracks, and the first set of tracks has an addition of a steel rod in the middle of all the wooden logs. The train was not made to run on steel rods, so as you see, it gradually gets worse and the train eventually slides off the track, causing the train to just stop early. In the next set of pictures, I had tracks where one of the wood logs was removed and therefore the train has trouble traveling along. It is able to get over the gap and keep going for a few of the cars, but eventually gives out and falls off the tracks and is not able to continue, and the train has to stop where it is. I then used what we were taught in problem session to determine the coding sequence. In these strands given, there was an insertion of an A that led to an early stop to the mutant strand. The mutant strand was shorter and could no longer continue. So here we have written out our normal and mutant amino acid sequences. We're going to use this to find the codon sequence. So for the normal and the mutant, we know it starts with AUG, so that stays the same. And then the next one is UGG, so that stays the same. But here we find the insertion of an A. So next, after this A, it was just inserted in here, so it's not going to be able to line up with one of the normal codons. So we line up this U, so we know this is going to be a U, and then we know this one's also going to be a U, so this one has to be AUU. Next we take this next one, and we know this one has to be a C, so we know that one is UUC. Then here we have an A, we know it either has to be an A, and then here we have a U and a C, and this one we only have C's, so we know this is CAC. Here is our complete coding sequence. Due to the insertion of the A, our sequence was shifted and caused the stop codon in the mutant sequence to occur before the normal sequence.